Hello everyone, this video is about trigonometric differentiation. In the MF19 we have this formula, sine becomes cos. So this means if we have sine f of x, the derivative is cos f of x, but remember the chain rule, we multiply by the derivative of the angle, the derivative of f prime of x. The derivative is f prime of x. And if we have uh, sine x to the power of n, this is using the algebraic rule, you bring the power down n times sine x, the new power is n minus 1, times the derivative of sine x, which is cos x. So for example, if y equals sine 2x plus 3, sine becomes cos, so the y prime is cos 2x plus 3 times the derivative of 2x plus 3, which is 2. And if y equals sine to the power of 4x or sine x to the power of 4, the derivative is 4 times sine x to the power of 3 times the derivative of cos x, which is sine x, or 4 sine cubed x cos x. Now if we combine both rules, if we have sine squared 4x, which is the same as sine 4x all squared, we bring the power down 2 times, exactly the same sine 4x, but the new power is 1, times the derivative of sine, which is cos, so cos 4x, but this is not just x, it's 4x, so we have to multiply by the derivative of 4x, which is 4. So if you simplify everything, this is what you get, 8 sine 4x cos 4x, and if you want to use the double angle formula, 4 sine 8x. The derivative of cos is minus sine, so cos something equals minus sine, exactly the same thing, times the derivative of the f of x. If we have cos x all to the power of n, we bring the power down, n times cos x to the power of n minus 1 times the derivative of cos, which is minus sine. For example, cos x squared, cos becomes minus sine, still x squared, exactly the same, the angle, and we multiply by the derivative of x squared, which is 2x. If y equals cos squared x, which is the same as cos x squared, we bring the power down 2 times cos x, the new power is 1, times the derivative of cos is minus sine. Combining both rules, if y equals cos cubed 4x squared plus 5x, or cos 4x squared plus 5x all to the power of 3, bring the power down 3 times, exactly the same, the new power is 2, times the derivative of cos 4x squared plus 5x, cos becomes minus sine, still exactly the same angle, 4x squared plus 5x, times the derivative of the angle. The derivative of 4x squared plus 5x is 8x plus 5. And then you can simplify everything here. 3 times minus, so minus 3 times 8x minus 24x, minus 3 times 5 minus 15. Of course we use the parentheses here. Tangent becomes secant squared, so tangent f of x becomes secant squared f of x times the derivative, and tangent x to the power of n times the new power is minus 1 times the derivative of tangent is secant squared. For example, tangent 2x cubed plus 4, the y prime is secant squared 2x cubed plus 4 times the derivative of 2x cubed plus 4, which is 6x squared. If y equals tangent to the power of 10x or tangent x to the power of 10, 10 times tangent x to the new power is 9 times the derivative of tangent, which is secant squared. Combining both rules, tangent squared x squared plus 2x plus 3 or tangent x squared plus 2x plus 3 squared. Bring the power down 2 times exactly the same in the square brackets here, exactly the same. The new power is 1 times the derivative of tangent, which is secant squared, exactly the same angle, times the derivative of the angle, which is 2x plus 2. And then we can simplify. 2 times 2x plus 2 is 4x plus 4. We use these parentheses, of course, and rewrite the rest. 3 more rules for trigonometric differentiation. We have secant becomes secant x plus secant x tangent x. Cosecant becomes minus cosecant cotangent. Cotangent becomes minus cosecant squared. Yeah, we can use all the chain rule formula again here. And for inverse tangent becomes 1 over 1 plus x squared. So if you have inverse tangent f of x, the derivative is 1 over 1 plus that f of x. So we have 1 over 1 plus exactly the same f of x squared times the derivative of the f of x. For example, y equals tangent 2x. So here we have 1 over 1 plus 2x all squared times the derivative of 2x, which is 2. If y equals tangent x over 3, so this time we have x over 3 here, and this 1/3 is because of the derivative of x to the power of 3. And usually we simplify this, so 3 times 1, 3 times, this is x squared over 9. If we multiply by 3, we get x squared over 3. And if we multiply both parts of the fraction by 3, we get 3 over 9 plus x squared, which is the simplest form. If y equals tangent 3x squared, we have 3x squared here, so 1 over 1 plus 3x squared, don't forget we have another square here, times the derivative of 3x squared, which is 6x. So this is what we get in the final answer. That's it. I'll see you again next time.